are you?
I'm new. I was wondering if you had any fresh water. I'm so thirsty.
You can fight me for it. Wait, well, no, I kind of have this soda. But what is this freshwater stuff you want for?
What do you mean, what is water? Water's vital to life. Everyone and every living thing on Earth depends on water. Water is the most essential thing on Earth.
Wow, water is so unique. Do you know more? I want to know more.
Well, water is made up of tiny molecules of hydrogen and oxygen bonded together. 2 hydrogen atoms and 1 oxygen atom bonded together make up 1 water molecule. Water is also the universal solvent, which means it can dissolve almost anything. You can see this by making a solution. A solute is a substance that can be dissolved by a solvent.
Hello, welcome back to my lab. Right now I'm about to make a solution with a solute, which is just a tablespoon of salt. And I'm going to mix it into 3 cups of water to make a solution. So, water, here's our salt. Just add our solute in. And mix it very well. And get all the little off the bottle. There we go. We have our solution with our solute added.
Of course there's more! Water is unique because it is the only element to exist in all 3 states. Gas, solid, and a liquid.
Welcome back. Last lab we have is the solid liquid gas lab. Right now we have a gas of the water. It exists, and how water exists in all forms. Gas form right here, liquid form, and solid, which is ice.
One of my favorite things about water is heat of fusion. Heat of fusion is the measure of the amount of energy needed to melt a given mass of a solid at its melting point. The formula for heat of fusion is this.
Where did you come from?
I came from my lab, what do you mean? I'm a scientist who specializes in water, and I'm here to inform both of you some things that you didn't know. Like, water is bonded with a hydrogen bond. A hydrogen bond is a type of chemical bond in which a hydrogen atom that has a covalent link with another atom. Or, I bet you didn't know about the specific heat formula. Ooh, the specific heat formula is used to find the amount of heat per unit mass required to raise temperature by 1 degree Celsius. The relationship between heat and temperature change is usually expressed in the form shown below, where C is the specific heat. The specific heat formula shows to get heat added, you get the specific heat times the mass times the change in temperature.
I'm kind of confused, but I love learning new things, so I'm just going to roll with it.
But I love this. Do you know anything about vapor pressure or polar covalence?
Of course I do. What do you mean? Vapor pressure is the pressure of the vapor over a liquid, and some solids, at equilibrium. Imagine a liquid in a closed box. Half of the box is full of the liquid. Of course, some of that liquid would evaporate and sit above the water, creating vapor pressure on the water. Speaking of the surface of water, the cohesive forces between molecules in a liquid are shared with all neighboring molecules. Those on the surface have no neighboring molecules above and thus exhibit stronger attractive forces upon their nearest neighbors on and below the surface. This can be seen using water, pepper, and dish soap to do this.
So in this lab we have pepper on top of water, and we put dish soap on there. The pepper scoots away from the dish soap. This proves because the surface tension of water, because the surface tension is very tight at first, and then the soap breaks down the water, allowing the pepper to sink to the bottom, but the water doesn't want that, so it just scoots away and it brings the pepper with it.
And polar covalent, don't get me started. Polar covalent bonding is a type of chemical bond where a pair of electrons is unequally shared between 2 atoms. And did you know, there's just one thing that I think you guys should know, is the difference between a calorie with a capital C, a calorie with a lowercase c, and a joule.
I know this. In chemistry, we measure heat using two different units, calories and joules. A calorie is defined as the amount of energy needed to raise the temperature of 1 gram of water in Celsius. The calorie you are most familiar with is used to measure the energy content of food. The calorie is actually a kilocalorie, 1,000 calories, and is written with a capital C to distinguish it from the calorie used in chemistry. 1 joule is 1 kilogram, M2/S2, which is also 0.2390 calories.
Good job, dude! Did you know about specific heat capacity? Specific heat capacity is the amount of energy required to raise the temperature of a substance per unit of mass. Joules or calorie per degree Celsius. My favorite thing is heat of evaporation, though. The heat absorbed per unit mass of a given material at its boiling point. That completely converts...
Wait, so if it boils, it must melt and freeze too.
Yeah, it freezes at 32 degrees Fahrenheit and 273.15 Kelvin. Yet most people don't know that the freezing and melting point are the same.
So here we are in my lab. We have a pot of water on the stove, which is just beginning to boil. I don't really know if you can tell, but right now it's at 170 degrees. And once it reaches 212 degrees Fahrenheit down here, it will begin boiling. So here we are. The water is currently boiling, and the temperature reads 212 degrees Fahrenheit.
Correct! This reminds me of the solution process. The formation of a solution from a solute and a solvent is a physical process, not a chemical one. Substances that are miscible, such as gases, form a single phase in all proportions when mixed.
Wow, I need some electrolytes, which is a compound that conducts an electrical element when it is in aqueous solution or melted.
Correct! And a non-electrolyte is a compound that does not conduct an electrical current in an either aqueous solution or in the molten state. Water that is chemically combined with a substance to form a hydrate and can be expelled, as by heating, without essentially altering the composition of the substance. A desiccant is a substance that induces or sustains a state of dryness, desiccation, in its vicinity. Efflorescence, a growth of salt crystals on a surface caused by evaporation of salt-laden water.
So right now in this lab we have an example of efflorescence, which I just boiled a pot of salt water, and as you can see, as the water boils away, salt gets left behind on the surface, which is efflorescence.
And a suspension is a heterogeneous mixture in which some of the particles settle out of the mixture upon standing. In the end, you need water to survive, and all those things come together to form H2O, and that is why it is unique.
Wait, so we need water to survive?
Of course.
Ugh.
She did.